Okay, question 3. Which of these means changing state from a solid to a gas? The same word applies if we go straight from a gas to a solid. So it's sublimation, and the process is sublimating, D. An object's got a mass in kilograms, fine, and a volume in meters cubed, fine. We've got to give our own unit, so we can leave that as it is. Calculate the density. So Dave's massive verruca, or we can use the rho sign. And it says calculate the density. I get to just use the equation I've got in front of me. So I'm going to take the mass and divide it by that. Make sure you use that button on your calculator so you don't make any daft mistakes using your times x to the power of 10. And then we're good to go. So you can see I've just moved the values. So that's getting dead confusing now. Divided by that, I'm left with kilograms divided by meters cubed, so my unit is kilograms per meters cubed. So quite a nice question. The next one, aluminium's got a melting point of 660 degrees C. The absolute zero temperature is minus 273 degrees C, which we call 0 Kelvin. Calculate the melting point in Kelvin. So what do we need to know? We just need to know Kelvin is always greater than degrees C, and if I want to convert that way, add 273. If I want to go back this way, take away 273. So I've just got to add 273 to that value. But just remember, Kelvin is a larger number than degrees C. So 933. On to the next part. Describe the motion of particles in a liquid. So they're touching each other, they're moving randomly, they're overlapping each other, and the particles in a liquid are moving faster than in a solid. So put that all together. Particles are moving randomly by overlapping each other, that is, they're touching, and the particles are moving faster in a liquid than they are in a solid. Okay, the next one. The student wants to determine the volume of a piece of metal by measuring the volume of water it displaces. So they're going to get a measuring cylinder, they're going to put some water in it, they're going to add the object, the water will rise, and we know that this difference between volume at the start and the volume at the end, that's the volume displaced. So we've just got to put that into words. So suggest 2 sentences. They could have included to provide a more. So I put some water in the measuring cylinder. Yeah, I'm okay with that. Or half fill a measuring cylinder. I put the piece of metal into the water in the measuring cylinder. So I would have added something like, I'm going to fully submerge it. I took the reading of the new water level. Okay, so what they haven't done is they haven't measured the initial volume, the starting volume. This was the volume of the piece of metal. No, we've got to subtract the two. So the crucial part is they really should have taken the volume at the start, find the volume at the end, which they've done, and then subtract those two. So that's the key bits of information. So what could they do to provide more? Ensure your eye is level when reading from the meniscus to avoid parallax. Ensure the metal is fully submerged, and the volume requires you to subtract the two values, and you should have measured the initial volume. Any of those. That's that done.